All right, this is Will, and we're going to try to talk about SCL for the box sorter project. And again, SCL, it's called structured coded language, or sometimes it's called structured text. It's more like a programming, C type program or that type of program, and you can run your PLCs off of it. And so what we have here is the standard. Now I've got this little move instruction. We'll go over that as we get into the program. But I'm going to put this into SCL. And what my program is going to look like in the final version, and we'll kind of run through this, but I've got this little start logic that I'm going to convert to SCL. Then my next block is a state machine, and then I have some case statements. And we'll go over that, and this might not be the best example for structured text, but at least it can show you some of the things you can do. So what we're going to do is we're going to add a new block, and I'm going to just call it my start stop logic, and this will just be a function. The difference between a function and a function block is a function block comes with memory, so we aren't going to have memory. We're going to call this I don't know, our start logic. And when you have the Siemens, you can pick your language. You can do it in ladder, you can do it in functional block diagrams, or you can do it in SCL. So we're going to pick SCL, and what it's going to give you, it starts a little, well, I don't know if it's intimidating, but it's just a blank screen. So what do you do with this? But if you look up on top, it gives you what you would do if you're writing a computer program. It says if. It's got while loops. It's got for loops. It's got things like that. And if we just go back for a second to our program, and if you think about it, we have if-then statements. If you consider the outputs, if you have a dividing line like right down here, all of these, they're conditions. They're if this is true, and if this is true, then I do this. So they are if-then statements. All these are if-then statements. So that's kind of the idea behind it. So if we look at this and this is true, but we have the CLN. The CLN is only around the start push button. So let's see what we have. And if we go, let's see. So if we go back into here, state machine, start logic is what I wanted. So this will be blank again. And the way we do this is we're going to say our start process, and it'll come up there. Now it's a colon equals, and that's the assignment for this. So what do we have? We have the start push button, or the CLN, which would be the start process. Okay, and I'll put the parenthesis around that, and the stop push button. The stop push button, and that'll be it. And then you have to put a semicolon at the end. So that's all it takes for this. Is we have the start push button. It's really the start push button, and this is going to get your start process. But over here is the OR is for the CLN circuit that just goes around. So that's all we need for that. And then we can say that our start lamp, doing the same process as colon equals, now this will be start process, and finish it with the semicolon. We'll do the same thing with the stop lamp. And now this time, this will be not start process. And that's all we have. And that's okay for that. Now we also have the thing where we had this move command. So if we look at this, and this is something that I need for the startup to get my little sequencer machine working, is I'm going to add in a start pulse, which this start pulse is at the very end. When I hit the start push button, I'm going to say system start pulse. So that'll be the same type of one shot that we've used before, and that's just going to move a 1 into this mode register, and the mode register is going to tell us what step we're on. So if we do that in let's see, our start logic, now this is going to be an if statement, so it'll be if, and call that system start pulse. Then, and once you type it up, it'll give you that. So if this is true, it's going to execute the next statement. If it's not true, then it's not going to execute it. So we have this mode, and we're just going to say that's going to equal 1. And that's that. So now I also have to put an end if down here. And they have all these different ends. If you just start typing end, you can figure out, is it a for, is it a while? So this is an end if. And you know, it kind of puts the, I don't know, the formatting correctly for you. So that's it. Now for this, we can go in and we can say, I want to just compile. And for all the blocks that you do, you can compile them independently, and down here it'll tell you no errors, no warnings, so that's good. So we'll close out here, and now we can just take this whole thing, so this whole network, we're just going to get inside the box. We're going to do Control A, and then we're just going to delete it, and we're just going to pull our start logic right up into there. Okay, so now let's talk about the state machine and case statements. And let's go back to well, first let's take a look. And this is kind of our roadmap, and I put little step numbers for each of these steps. And the 0, 1, and 2 kind of happen kind of quickly, but we'll show those. But you have this, well, for instance, if we're in this step 5, we have, for our outputs, we have the entry conveyor on, we have the load conveyor on, and during step 5, those outputs stay in that frame until we get that transfer trigger is what we call it, and then we just jump to a different set of circumstances. Now, if we look at that in a different way, so this is kind of a state diagram, and our state 0 is kind of an idle state, and then when we hit the start push button, we send off that one shot, and that's for one scan, and that kind of sets up our start pulse. And what that does is it first moves that value of 1 into the mode register. So these S0, S1, S2, S3, those are the same as mode. So this is mode 0. When we hit the start push button, we move that into the register, the mode register, so it's at 1. Since it's only high for one scan, then it goes away. And then we set up the emitter, and when the emitter goes away, we set up the entry conveyor. So and then you come down here, and when you hit the pallet sensor, which then you determine whether it's a high box or a low box. So just like you have the same instructions in ladder logic or functional block diagrams, this is for the high box over here. is the way I had it written down, and this is low box. And then, you know, when we get, just like the other programs, when we hit that exit trigger, you know, the very end of the pallet goes past the exit point, you know, then we count our pallets processed, and then we jump all the way back here to step 2, which is going to do our emitter again for the second time around. So let's take a look, I guess, at the state machine, and what does it tell us? So basically, in all these steps, so you know, this state machine isn't even running until we get that mode equals 1. So, you know, we get that mode equals 1. If we look at our main program, what happens is, you know, when we hit the start push button and on our start logic, you know, as soon as we hit that start push button, you know, we put the 1 into the register. So that basically starts off the machine. And you have to be careful when you're clicking on these to get below it. So we're going to have the mode equals 1, and we're going to have the start pulse for 1 scan. And so what that says is we're starting our process. And then, and if we look at this, and so anyway, then we just go to mode 2. And when it's mode 2 and the system pulse goes away, which is only good for 1 scan, then we drop the emitter. So this state diagram, this is kind of the instructions, but the other, what we have, the case statements, and I'll have to flip back and forth between these two, but and also we have to talk about this. So end of cycle. For case 1, we aren't really doing anything, but we want to make sure that that's the end of cycle is false, because when we finish off the other, you know, at the very bottom here, we're going to say that the end of cycle is true, so then we have to make it false again when we begin. And because after the first time we jump back into the program at step 2, then it's also here. But basically, step 2 makes our emitter true. Step 3 makes our emitter false. And by virtue of that, then the conveyor also comes on. So let's take a look, and I think we kind of show that one version of the state machine. And if we look at the first page, we kind of have it starting out at state 3. But that's what happens is we create our emitter. You know, the first step just kind of clears the end of cycle. The second step kind of gives us an emitter. The third step, it goes away. So it's going away, and let's take a look here. So right now, if we're in step 4, what we have is, well, here's step 3. The emitter's false and the conveyor entry is true. So it's running down the conveyor. So when we look at this, it's like right here in this step. It's not doing anything. Well, it's just running down the conveyor. And that's what's going to happen until we get the height strobe. And that's when the pallet senses, or is sensed, and then when we determine whether it's high or low. So if we go back here, when the pallet, so we're in step 3, and this is what we're doing. We've got the emitter off and we've got the conveyor on. And if we go back to, you know, we're going to stay there until, if we look at the state machine language, it's going to say we're going to stay in there until we don't have the emitter, which we won't. And then we also get the load conveyor trigger, which the load conveyor trigger, if you remember, is when the pallet sensor senses you know, the pallet going by, and that's when we tell that little section, the load conveyor, to turn on. So basically when that trigger goes off is when we jump to mode 4. So when we're in mode 3, and sorry to have to keep jumping back and forth, when we're in mode 3, we just have the emitters off and the conveyors on. Then we go to 4, after the pallet is sent, we also turn on that little load conveyor, okay? And then we have both the load conveyor and the entry conveyor on. Now, step 5, and this is where all we do is step 5 is we determine whether it's a high box or a low box. So what happens is when it makes that determination, it either jumps into step 5 or it jumps into step 9. So step 9 is the low box. So 5, 6, 7, and 8 are the same as 9, 10, 11, 12, except one's for left and one's for right. And, you know, it kind of follows the same thing, the same fashion that we did with both ladder logic and, you know, the functional block diagram. We're kind of waiting. And at step 5, when we're in step 5 and we're waiting to go to step 6, if you look at the state, from 5 to 6 is right here. We're waiting for that trigger transfer. And when we get that trigger transfer, that's when a lot of things happen. So this trigger transfer is right here, and that's where we turn off the load conveyor, we turn off the entry conveyor, and then we start turning on the transfer either right or left, and the output conveyor either right or left. So based on whether it's a high box or a low box will be you know, which path you go on. And so, you know, we kind of do the same steps as we did in either one, and it's all just what you're doing in each of the steps is governed by, you know, what step you're on, and you're just telling things to turn on or turn off. You know, true is active, is on, false is deactivated, or you know, logic 0. So we're just saying these are true or these are false, and we're just walking all the way through with that. And you know, it's you know, it's not anything visual. It's a lot harder to try to troubleshoot. But you can, and so we'll take a look at what you can do. So the things you can do is you can actually, and we'll show what state the bits are in, but the other thing you have in Siemens, and you know, I didn't talk about it in either ladder logic or functional block diagram, but a really important thing is this watch table. So you can take a look at, and I had to troubleshoot this, and I was having some problems, but I put in some timers and I didn't really need them. But you know, I needed to know end of cycle, I need to know my mode, I need to know what the count is, I need my start process and my emitter, and this will show you in real time what's happening, and we'll take a look at that. So so all you're doing is, you know, the contents of the case is just saying what's on and what's off at any particular time, and you know, your state machine is just guiding you from one step to another step. So here, you know, it's a transfer trigger that does something. Here, it's when you're left entry, and you know, here is what we say is let's try to move this over and see how far we can. And you know, there's little comments in here that, you know, here's where we have the entry conveyor, here's where we determine the box height, and you know, here's where you make the jump to either step 5 or step 9. So we have those in there. So yes, right now I'm kind of out of the program, so let me go offline, and I'm going to run the simulation. And we get our usual messages flashing. Yeah, that, and a lot of times what they use structured text for is when you're handling lots of data, and you know, now everything is data driven, and so they want to know, they want to store values remotely, and you can do it much more efficiently with you know, actual programming language rather than you know, you certainly can't do stuff like that with ladder logic. It's really difficult, but it's an easier thing to do a lot of data manipulation and data handling with this type of program language, especially with while loops and for loops. You can move chunks of data a lot better. So let's see if this is ready to go. And this is going to work the same way as the other versions. It's just a different way to look at these. If you're good with programming like robotics, you might find that this is more of a cup of tea than ladder logic. I think and when you do this, like we showed that initial startup logic that we had, you might say, why in the world would you ever write that in structured text? And you wouldn't. I mean, you would put it in regular ladder logic, or you put it in like a set reset with like functional block diagram. You wouldn't want to write it there. That was just kind of showing you what it kind of looks like, because it does look a lot different than everything else. So if we get our green lights, or our green circles. Oh, okay, I think we're okay. Now we'll go online, and then we'll get our green circles. And when you turn this on, now it's going to, there's a lot of data, but like right now it's showing you that everything is false. And if you wanted to take a look at individual terms in here, you can see, well, the value of right now, the mode is 0 because we're not doing anything. It's saying the emitter is false, and that's false. So you can, do some troubleshooting here. It's a little more difficult. I think actually the better way, you can take a look at these watch tables, and we can actually, when we're running the program, and here you need to individually start it up, but it's saying that, we're basically not running. So let's go back to our FactoryIO, and the first thing we need to do is, I don't know if we're connected, so we go into drivers, and we're not connected. So we try to connect up, and that red will turn to a green check mark if everything is going good. Okay, so now we'll reset it. We'll put it here, and looks like we're in good shape to start. So let's just let's just run it and see what it looks like. And again, it should be what we've seen before, and nothing new here. Now it does do a little, well, I mean, you'll take a look at it. It is pretty much what we had before. Just runs a little bit different. It's the way that, and it's not the best of conditions, but the way I had to put in the end of cycle, it sort of, I think at least it loses a little continuity right at the end. But it's not that noticeable. So if we're in here and we're taking a look at this, like you can watch the steps. So when it's doing this 5, 6, 7, I know it's a high box. And you can see where it reset, you could see that quick blip on the end of cycle. But you can pull up any tag you want if, where it says add new tag. If we wanted to, well, if we just wanted to see our entry conveyor when it's on. So we're just going to oh, it's called conveyor entry. That's why it's not there. But anyway, this will show you when it's on, and then when it turns off. And again, it's on step 3, so it's moving up. And again, here is where, and I wonder if I sort of, by doing that, I kind of got everything stuck there. Let me stop it and run it again. Yep. I guess I gotta stop it, reset it. And maybe that was something. You gotta wait until you get the finger to turn it on. Your little press. If you just have an arrow, it's not going to work. So let's wait until we get another box, and then we'll take a look at the entry conveyor. I don't know if by selecting that, if I kind of caused a problem there. I think I did, because it should work pretty smooth. So you can see the conveyor's entries on, and you're in step 3. Now in step 5 it turns off because it's making the transfer. So really, I think this watch table is really useful. I mean, you can try to look at some of these, if we wanted to go into the state machine, take a look at that for a second. You can kind of follow it on its path. This is kind of good for, you can kind of follow it when this is true, and it's only true for a very short period of time for that step. But if it's not working, it stops at a step. You can say, well, it just stopped at my step number 3, and I'm not quite sure why. You can kind of take a look at what condition these are in, and that can help you out with it. I think, well, the 2 best things you can do for trying to figure this out, 2 screens is really helpful. If you can be looking at the watch table and you can be watching FactoryIO at the same time, that's a real benefit. So if you have 2 screens, that's the way to go. I guess the one last thing, and I hadn't really shown this, but I pulled it up for this because if you look in the that's not what I wanted. If you look in the S7 1200 manual, it's a really long manual. It's 800 and some pages. But what it has is it has all these instructions, what they look like in ladder logic, what they look like in functional block diagram, and what they look like in SCL. So this gives you something to start if you want to figure out how to do this. Now, one thing you need to be, let me go up here and show some basic bit functions, is SCL doesn't inherently have a lot of the bit functions that we use all the time, especially like our edge triggers, which are my best friends. So that's why in this program I have them separate in a separate rung by themselves, or a separate network. So you can see that for a lot of these things there's no SCL equivalent. And when they say there's no equivalent, sometimes you can write your own, like here for, well, that's not the one we want, but here for, these are our edge instructions. You can write your own code to do these functions, but again, it's why would you? I mean, I have this thing right here that I can use and it works fine. So, I think, as far as I'm concerned, that, what we do is if we need something like that, we just put them at the top of the program, and, as we have them in all our programs. So we've got this as kind of ladder logic. Down here, this start logic, we could make this block, right now it's structured text, but you really wouldn't want to do it that way. I mean, if you were doing this, and maybe a good thing to do is maybe try to combine them all, but you could do this as functional block diagram, and then you can put these as SCL if you wanted to. But I think it's more complicated, but there are some really good uses for it, and sometimes it can help you out of situations that it's not easily doable with ladder logic or functional block diagram. And it's really good if you're handling a lot of data. I know this isn't the best example for its usage, but it just kind of shows you what it looks like and how you might want to take a look at it. So anyway, there are 3 different views for how you can do with Siemens. And again, if you don't have the Siemens, you can get a 2-week trial. I think that's a great thing that Siemens offers. And if you just want to, if you have a little free time, now that everybody's quarantined, I guess you can, try it out for 2 weeks and try these different languages. See how it works out for you.